so here we go. It's Tuesday, May 5th, Cinco de Mayo, also Taco Tuesday. Mr. Martin, is there something I can help you with? All right. You guys want to work on Lowry's or Foley's class instead of algebra?
Yes.
Want to do that? Okay, well then why don't you just drop off the class and go do that? Okay?
Got you.
Drop off the class and go do that.
Now I'm okay.
I was just trying to figure out what I missed. Sorry.
Yeah, that's all right. You want me to give you my screen, Mr. Martin? You
I'm tripping. Oh, Graham, we had took a test.
Zion, be quiet. We're in a different class.
Yeah. Thank you, Mr. Martin, for starting this discussion on English instead of Algebra 1. I got you.
You asked me.
2 50-minute classes. If anybody wants to do English, you can go do that now. Or if you're going to continue to chat either verbally or with a chat box on English, I'm going to remove you from the class and I'll give you a 0 for the day. And you'll lose 40 points of your rep grade for the week. Okay?
Every time I do something, it's a problem.
Mr. Hughes or Mr. Hunter, I know you're always a victim, all right? I get that. You're always a victim. You're always a victim. All right, so here we go. We are moving on to Chapter 6 in Section 6.1, Graphing Systems of Equations, okay? Systems of equations is a fancy term meaning I've got 2 lines, all right? That's a system of equations. Now, you guys that struggled with putting equations into slope-intercept format and then learning how to graph that from the y-intercept and the slope are really going to struggle with this section. And that's why we spent so much time on it, and hopefully you become proficient. If not, this is going to be a tough section for you. All right, so let me go over the basics of this because I'm just going to spend one day on graphing and then we're going to solve them algebraically, but I want to give you a visual appearance of what the lesson is so that when we do it algebraically on Thursday, hopefully it'll make more sense, all right? So a system of equations is just 2 equations, just a fancy way of saying that, all right? It could be more, but in our case, it's going to be 2 or more linear equations involving the same variables form a system of equations. So it's just 2 equations, that's all that is. Now I've loaded both this problem set and also the next problem set on Blackboard for today. One's a CLD 0505 and one's that's class lecture and discussion. One's a CHW, which is class and homework, classwork and homework 0505, okay? So if I've got 2 lines, all right, one of 3 things can happen with those 2 lines, how they interact or relate to each other, all right? They can, they can intersect each other. We've got 1 point in common, all right? 2, they can be the exact same line. You may not know that because the equations on the surface look dramatically different. But if you would simplify the equations, they would boil down to the exact same thing. So they are the exact same line. Sometimes we use the term coincide, and they're going to have an infinite number of points in common as opposed to just 1 point in common if they intersect. So infinite means they can have, you know, a gazillion different points in common. The third possible relationship or outcome or relationship between 2 lines is that they parallel, meaning they have the exact same slopes. And we've talked about this back, 10, 12, 14 weeks ago. Have the exact same slopes, but different y-intercepts. And they've got no points in common, okay? Everybody have that basic understanding? That should be a little bit of a review, but there's only 3 outcomes that 2 lines can have in relation to each other. They can intersect with 1 point in common. They can actually be the exact same line, even though the equations are going to look or appear differently on the onset. And they'll have an infinite number of points in common, or they've got the exact same slope, different y-intercepts. They never touch each other, and so they have no points in common. All right. Anything I can clear up on that? Any confusion? All right. So let's look at these scenarios. Okay. Says use the graph at the right to determine whether each system is intersecting, parallel, or the exact same line. They coincide. So we got y equals negative x plus 2. All right. That is this line right here. How did we know that? All right. It has the y-intercept of 2 right here. It's got a slope of -1, so it's down 1 over 1, down 1 over 1, down 1 over 1. All right? So that's one of the lines. Let's look at this line, y equals x plus 1. That is this line right here, right? Has the y-intercept of plus 1. It's got a slope of 1 over 1. So actually, those are perpendicular lines, right? They've got negative reciprocals of each other. So the answer to this line is that they intersect, okay? I'm not going to spell out the whole word since I can't write with this thing. And they've got 1 point in common, which right here is about 1/2.
After this class, I'll have to get off because I gotta do my I did an essay.
Is that for me? I'm not sure who you're talking to, but okay. All right. So that's an intersecting relationship between this. Intersecting relationship, 1 point in common. Any questions on that? All right. Let's look at the next one. You got y equals negative x plus 2. We just did that line. That's this one right here. It's already nicely labeled for you. Okay. And we got, what else? We got 3x plus 3y equals -3. Now, we could put that in slope-intercept form, but due to the lack of time, because I'm going to cover everything, that's this line right here, all right? If I divide everything by 3, I get x. Let's go ahead and do it just so we can relate the stuff we already know. If I divided everything by 3, I get x plus y equals what? -3. And if I then put this in slope-intercept form, I get y equals, I'm going to wedge it right in there, -x minus 3. All right? Does that make sense? Oops, -1. It should be -1. X minus 1. There it is in slope-intercept form. See what I did? I just divided the whole thing by 3, and I moved the x over to the other side. So these two lines are the exact same thing, all right? There it is in purple. That's why it goes through -1 for the y-intercept. So these two lines here are parallel, right? Abbreviate. Sometimes we demonstrate parallel as a symbol like this. That right there means the lines are parallel and they have no points in common. All right. Questions on that one? All right. Third scenario. There's that exact same line. That's this guy right here. And then the other one is this one, y equals -x minus 1. And that is the exact same line. Remember, I just converted that -3x. These don't look like the exact same lines, but you saw in that previous problem when I rewrote 3x plus 3y equals -3 into slope-intercept form and divide everything by 3, you can see they're the exact same line. So these lines coincide, all right? Exact same line. Coincides another term, and they've got infinite number of points in common. Sorry for the lousy handwriting. All right, any questions on that? Make sense? Any confusion? Okay. This is loaded up into Blackboard. All right, I'm going to walk you through these, and then the next problem set we're going to do partially in class, and you're going to do some for homework. All right, so let's look at these. All right, and this is really just a kind of a carbon copy of what was up on front. So we got y equals -x minus 3. We're supposed to what is the relationship of these four systems of equations? So we got y equals negative x minus 3, which is this line, okay? And we've got y equals x minus 1, which is this line, okay? All right. So they are intersecting. And ask me a question if you don't agree or don't understand where we're coming from. And they've got one point in common, which is right there, which is a -1. We're going to solve these algebraically on Thursday. -1, -2. So if I put -1, -2 into each one of these equations, let's just do it real quick. I get -2 in here. Right, here's my y equals, all right, here's my x. So I put -1 in for x. I now have a +1 minus 3, right? So -2 minus 3 equals a -2. So that is a true statement and it solves the equation. Likewise, bear with me here. Now, if I do the same thing here and on this equation, and I plug in -2 for the y, and I plug in x is -1, right? -1. Right? -1 minus 1 is a -2, and once again, I get -2 equals -2, right? That is the only point that both these equations, when they're solved, equal the exact same thing. Does that make sense? Questions? All right, next one. I'm going to do this one first since it's already simplified. Y equals -x minus 3. That's this guy right here. Okay, I'll underline it. Let me change the color real quick. 2x plus 2y equals -6. And you could see we could simplify that. And if I did, that actually is the exact same line, right? Because if I simplified this, I could and divide everything by 2, I would get x. Because everything's divisible by 2, I get x plus y equals -3, right? Does that make sense? Look familiar? And then if I move that x to the other side, I subtract x from both sides, I get y equals -x minus 3, and I got two identical equations. So this system of equations of number 2 is the same line. You can either write same line or you can write coincide. All right? And they've got infinite number of points in common. And that's that kind of horizontal 8, or that 8 that's lying down, because they've got infinite number of points in common. Questions on that guy? Any confusion? All right, let's look at y equals -x minus 3. There's that same line again. That's this guy right here. And then we've got, 2x plus 2y equals 4. Where'd that one go? That's this guy right here. Let's look at that 2x plus 2y equals 4. We can see each one of those is divisible by 2, and I would get x plus y, sorry about this for the writing, equals 2. And I can simplify that into slope-intercept format. I get y equals -x plus 2, right? If I rewrite that. Now, if you look at this guy, now look at this equation, reference the other equation. That's y equals -x minus 3. Exact same slope of -1 on both equations, just different y-intercepts. So these two, I'm just going to use my symbology since I can't write, is parallel lines, and they have how many points in common? 0, zip, nada, none, right? Parallel lines have no points in common. Questions on that? The vast majority of these are going to be intersecting lines with one point in common, because that's what we're going to be solving for on Thursday when we solve these algebraically. Any question before I do the last one on this page? Anybody?
So you just choose one problem and then you look at the line and then just simplify it if you can.
Well, in these, I would just, well, let's do this one together. Let's do this one. All right, so if we look at this guy, all right, I don't need to because the lines are already labeled with the right equation. But if I was going to graph this and I didn't know which one of those lines it was, this line in slope-intercept form, which I like the best because it allows me to graph it by plotting the y-intercept and then using the slope to solve. This one right here, if I rewrote it in slope-intercept form, is y equals negative 3x plus 3, which means it has a y-intercept of plus 3, which is right here, right? And it has a slope of negative 3. That's all stuff we learned several months ago. It has a slope of negative 3, which means, remember, it's rise over run. So I would go down 3 and over 1. And there's a point. And I can go down 3 and over 1. And there's a point, and so on. All right? So that's that line. So this bottom line is this purple line. All right, let me change my color here and do something different. Let's use this guy for this one. All right, I can convert that to slope-intercept form by dividing everything by 2 and then subtracting the x and moving it to the other side. And let's see, where is that one? That is this line right here. Okay, agree? Let's see here. Because if I converted this to slope-intercept form, let's just do it for practice. I would have x plus y equals negative 3, right? X plus y equals negative 3, dividing all this by 2, right? And then if I move that x to the other side, in slope-intercept form, which we love, is y equals negative x, minus 3. Did I say plus 3? So it's x plus y equals negative 3. So again, if I move that x to the side, I subtract x from both sides. You can see it goes through. There's my y-intercept of negative 3. All right. So this system of equations, number 4, are intersecting. All right. And they intersect right here. Looks like right here, which would be 1, 2, 3, 3 over 3 and down 2, 4, 6. It looks like they would intersect at 3, negative 6. All right, does that make sense?
Kind of. We're gonna go over the next problem set, right?
I'm gonna get you started. All right, it kind of builds on this. But the basic tools you need to understand this is to be able to be able to put lines in slope-intercept form and be able to graph them. All right, so you just put them in y equals mx plus b form. You plot that y-intercept, and then you use that slope, which is that coefficient in front of the x, once you have it in y equals mx plus b format, to get 1 or 2 points to plot the line.
Okay, I understand it a little better with that.
All right, any other questions? All right, let's do something else here. Let me, give me 1 second, bear with me. Just give me 1 second. I gotta come out of share screen because I got another one. Now, let's see if I can. All right. So this is already loaded on Blackbot for you. All right. So we're going to kind of build. We're going to build on what we already learned. All right. So if you've got a printer at home, my suggestion would be to print out that first problem set and use that as a reference and a resource. All right. If you want to do those problems for a refresher or warm up to doing this, then that's fine also. Okay. So, all right. So we're going to. What we're going to do here is we're going to solve these by graphing. Like I said, on Thursday, we're going to solve them algebraically, all right? We're going to solve a system of equations. Remember, system of equations is just two lines. It's a fancy name to say two lines, and how do they relate to each other? All right. You've got two examples you can use as a reference, and let me just walk you through these. All right. So it says graph each system and determine the number of solutions that it has. All right. So it's either going to have one solution as an ordered pair because they intersect. It's going to have no solutions because they're parallel and they never touch each other. Or it's going to be infinite solutions because it's the exact same line, they coincide. So those are the only three possible outcomes that you can have here. So let's look at this guy. So I'm going to just put this in slope format, and we get y equals negative x plus 2. It's already graphed for you, but you're going to have to do this down below. So that's why I'm doing it. So I'm going to plot the y-intercept right there is positive 2, and my slope is negative 1, right? So it's down 1 over 1, down 1 over 1, down 1 over 1. All right, so that's that line. And in this line, I'm going to subtract the x from both sides. So I end up with negative y equals negative x plus 4. Okay, agree? Everybody see what I just did there? But slope-intercept format is y equals mx plus b, not negative y equals mx plus b. So I've got to multiply everything by a negative 1. All right, so this becomes becomes positive. This becomes positive, and this now becomes negative. All right. Oops. Where's my pen? All right, so if I'm going to graph this, it's negative 4. There's my y-intercept. My slope is 1, right? Because that's what's the coefficient is in front of that x. That's where my m is. So it's up 1 over 1, up 1 over 1. All right. The lines actually cross right here. And they cross at 3, negative 1. Mr. Hughes, got a question?
Can I please go to the bathroom?
Yes, sir. All right. Okay, so that's what you're going to do. I'm not going to do number 2. You can use that as a reference on a resource. All right, so if there's no questions, I'm going to, let's see, how many we got? We got 1, 2, 3. We got 6 of them. All right, I'm going to walk you through at least 1, maybe 2, and then you're going to do the remaining 4 or 5. Any questions before I move on? Any questions? Are we good? All right, here we go. All right. So I got to graph y equals negative 2. Someone tell me can I graph that line? Is that line is that a graphable line?
Yes.
Tell me how to do that. I think it was Mr. Clark, maybe.
So you would go down 2 on the y-axis.
Exactly right. And what kind of line would it be?
That would be horizontal.
Horizontal line. So it's going to look just like this, right?
Roughly, yes.
Yeah, roughly like that. That's actually pretty good in my book. Meaning that it's a horizontal line. Every point in that line has negative 2 as the y part of the ordered pair. You got 0, negative 2. You got 1, negative 2. You got 2, negative 2. You got 3, negative 2. And there's an infinite number of points. Okay? So that's that guy. Now let's do the other guy. All right? I can't graph it in this format, so I'm going to convert it to slope-intercept form. Okay? So I'm going to subtract 3x from both sides. Okay? So I can't write very well. And I'm going to end up with negative y equals, that equals not inequality, negative 3x minus 1, right? This is kind of like the example. I can't have a slope-intercept form as y equals mx plus b, not negative y equals something. So I multiply everything by a negative, which makes that y now positive. It makes that 3x now positive, and it makes come on, it makes that now positive.
Why does it make them positive?
Because when I move that 3x over to the right side of the equation, I had the equation negative y equals negative 3x minus 1. That's not slope-intercept form because that y has to be positive. So to get that y positive, you multiply or divide, whichever, same difference, will convert that y to a positive, and then you can graph it. So by multiplying everything by -1, the signs of everything reverse from what they originally were.
And then mx, or then the rest of the problem to the right of the equal sign, if they're negatives, also become positives, right?
Every sign would reverse. Every sign would change from whatever it was to new. I'm just rewriting this. So this equation put in slope-intercept form is now this. Now I can graph it, all right? So I know it goes through. So I plot the y-intercept, which is 1, right? Y equals mx plus b. B is my y-intercept. My slope is a positive 3, all right? So I go up 3 and over 1, which would be right about there. And just to help me draw the line, I go down 3 and over 1, which would be about right there. It's going to be a squiggly line just because it's hard to do. And that would be the line, all right? So how do we solve this graphically? All right, so my answer would be they intersect. You can abbreviate it. I'm going to abbreviate it since I can't write with this. And then tell me what point or points they have in common. So the point in common for both of these is -1. X always comes first. That's why it's called ordered pairs. The order is significant. -1, -2. That is where they intersect. All right.
So what you do is you just graph the equation on the top, and then that'll give you your first line, and then you graph the equation on the bottom, and then that'll tell you if it's intersecting or what.
Yeah, once you graph the two lines, and you may have to put the line in slope-intercept form to graph it if it's not already done so for you, all right? Once you've graphed both lines, visually it's going to show you, or graphically it's going to show you what the relationship is between those two lines slant system of equations, all right? Let me talk about this. You've got to know how to graph that. And you know, what's missing in this equation right here? It's in slope-intercept form, but what's actually missing? Or what do I have? I mean, I'll take either one.
Slope is 0.
Right, my slope is 0. So it'd be y equals 0x minus 2. That minus 2 is my y-intercept, right? When my slope is 0, I know I'm always going to have a horizontal line, right? Because it doesn't go up, it doesn't go down. Remember, slope is rise over run. Right? So just as a refresher, so anytime y equals just a numerical value, it's going to be a horizontal line with every point on that line having the exact same y value of whatever that is. In this case, -2. Are we good? Questions before I move on?
Sir, I actually have something to remember at horizontal line. It's hoy.
I'm sorry, say it again.
It's hoy, like H-O-Y, like horizontal, 0 for the slope, and then knowing that it's y.
Okay. Everybody here? Did everybody hear Mr. Clark? That's one way you can kind of put it in the memory bank. H-O-Y.
Same thing with vertical. Same thing with vertical.
The slope is 0, and you got the y.
Vertical, I say vux. Vertical, undefined, and then you know it's x.
All right. So you got hoy and vux. All right, that's good trick. All right, let me clean up my stuff here. All right, so let's look at this guy. instead of having y equals something, now I've got x equals something. Right, so maybe using Mr. Clark's Vuck's suggestion, all right, the slope is undefined. An undefined slope is always going to be a vertical line. So Mr. Clark, where would this line go?
Up and down on the 2 on the right.
Right, x equals 2. So this is the line of x equals 2. Everybody agree? All right, I like that technique, Mr. Clark. Boy and Bucks. All right, so now this guy, all right, I've got to, let's see. Over here. All right, so I've got to put that in slope-intercept format to be able to graph that line. So the only thing I need to do is to move that 2x over to the other side of the equation by subtracting it from both sides. So I end up with y equals negative 2x plus 1. Right?
So, and you said you do that by subtracting y?
The y, I didn't move the y at all. What did I move?
The X.
I moved the 2x, right? Right.
So you subtracted 2x.
I had to move the 2x from the left side of the equation to the right side, so I just subtracted it. Remember the properties of equations. I can do anything I want to the equation as long as I do the exact same thing to both sides. So if I subtract 2x from here, that zeroes out. And I got to subtract 2x over on this side, right? Were you caught up? All right, so let's graph this line. Y equals negative 2x plus 1. All right, so this goes through, there's plus 1. There's my y-intercept right there. Y equals negative 2x plus 1. What's my slope of that line?
For which one? For the Y.
The red line, the red equation.
It would be up or down 2 over 1.
Right, the slope is negative 2. So I'm going to go down 2 over 1. So there's a point. I'm going to go down 2 over 1. Actually, there's a point. That's where they intersect. All right, so I got 3 points. That's one more than I actually need. So the graph of that line looks like this. So the answer you're going to put is they intersect, because there's 3 possible outcomes. They could intersect, they could be parallel, or they could coincide. So they intersect, and when you intersect, they've got 1 point in common. So we know that's 2 over 2 and down 1, 2, 3, negative 3. Okay. Questions on number 2? All right. I'm going to just give you a couple things to think about on number 3, and then I'm going to do like a summary, and I need to do a couple housekeeping chores with you guys. All right. So this guy here, I'm not going to do it, but I'm just going to give you some things to think about. If you don't have a printer at home and can't print this out, just do it on loose leaf paper and just going to try to draw a pretty decent, respectable graph, and then put it in Dropbox by tomorrow night at 6 o'clock so I can take a look at how we're doing on this. So if I'm going to graph this, one is, can I graph this?
Yes.
How? Give me a start. Tell me how do I start? Because I'm missing something.
You are missing a y-intercept.
Missing a y-intercept. So if it's not there, what is my y-intercept?
1/2.
0.
1/2. Why do we say 1/2?
Because it says y on the equals 1/2 x.
What's the coefficient in front of x always represent?
Slope.
Slope, not the y-intercept. All right, somebody said 0. Why did you say 0?
Trying to.
There's nothing next.
There's nothing here, all right? So my y-intercept is 0. Okay, my y-intercept is 0. Now you've got the slope, and you can graph it. Rise of 1 or run of 2, all right? To graph this, you have to do one thing before you can graph it. What do you have to do in the second equation?
Subtract x from both sides.
Subtract x from both sides. And then you've got it in slope-intercept form. You can plot the y-intercept. And we know if we move that x to the side, it's negative x. So my slope is -1. So we know that line is going to be descending to the right. Okay? All right. So so you got number 3 to do, and you got 4, 5, and 6. You only got 4 problems to do. Do that and put that in Dropbox by tomorrow evening so I can grade them tomorrow night. We can talk about them in further detail on Thursday. Let me go over a couple housekeeping chores. All right, we've only got 5 more classes together. A lot of you got zeros on various things. You may have submitted a quiz or a problem set to me, but didn't put your name on it. I've got a stack of probably 20 problem sets and quizzes, a stack of about 20 documents over there, both problem sets and quizzes with no names. So I would suggest for you between now and Thursday, look at your grade book and Blackboard and see if you're missing anything. And if you've got a 0 for something you submitted, resubmit it and I will grade it. All right. I'm not going to take late work the last 2 weeks of the class, but a lot of you have a lot of zeros. All right. It's up to you to go back. And like I said, you may think, oh, I've submitted everything, but if you submitted something without a name on it and I couldn't recognize your handwriting, you don't have something real distinct or unique.
Mr. Gaffney, I put my name on my paper already.
You don't have something real distinct, unique handwriting. I can't just arbitrarily assign a name to it. So go back and check Blackboard. Once again, it's on recording. I'm not taking late work the last 2 weeks of the quarter. We're not going to
Mr. Gaffney.
We're not going to. Would you quit interrupting me, Mr. Hunter? We're not going to be scrambling for grades the last weeks of the quarter. What it is what it is.
How many more weeks we have?
If you talk to Mr. Campbell, Mr. Hunter, please don't overtalk me. All right. If you see Mr. Campbell, tell him to submit his test. Mr. Gilmartin, you owe me page 1. Mr. Hughes, you're going to give me something other than a video of the test. Mr. Seeley, you're going to submit a test. This probably is our only test this quarter, so by not doing it, you're going to take a major hit and probably have real extreme difficulty passing for the quarter. All right? But once again, I'm not taking any late work the next 2 weeks, so this is the week to submit any late work. Make sure you download this problem set and finish 3, 4, 5, and 6 by tomorrow evening so we can use that to pick up from when we resume class on Thursday.
3, 4, 5, 6.
All right. Any questions?
Mr. Gaffney, what problem set is this? My bad. I forgot.
It's, give me 1 second. It's 6-1, problem set number 2. 6-1, problem set number 2. There's also a 6-1, problem set number 1, which is that first one. We work through that collectively. So you may want to do that just for practice and refresher and, mastering the material. But it's number 2 that I'm going to look at in preparation for what we're going to do on.
Got you. Mr. Gaffney,
Mm-hmm.
can you send me 6-1 and 6-2? I mean, 6-1 problem set 1 and problem set 2 because I don't see my work in Blackboard, and I can't submit it to Blackboard either.
If you go to CHW 0505 and CLD 0505, there's one on each.
COD 005. What?
It's in today's assignment. Class, lecture, and discussion. It's from your syllabus that we've been operating off of for the last 8 months. Grab it there. If you
Yes,
can't grab
sir.
it, send me an email. Any other questions or comments other than Mr. Hunter?
I don't have it. Okay.
And I already addressed that
Mr.
scenario.
Gaffney, so I was checking my grades. It said I had a 91, but yesterday when I checked, it said I had a 95. I was just wondering, how did my grade drop 4 points?
Why am I still at an 86?
Mr. Kelly, then it's probably due to this test score that I entered a little bit ago. The test score may curve depending on these guys.
Well, I got an 87 on the test, but I don't see how that would drop my grade 4 points.
Because it's 35% of your quarterly grade.
Okay, so are we having another test? And if I do better on that one, will
Most likely not, because we only have 5 more classes together. Curve them depending on what happens for the 3 or 4 tests I'm still missing. So it may go up a little bit,
Okay.
okay?
Bye, sir.
All right, any other questions before we go?
No, sir.
All right, so both of those are submitted tomorrow, right?
Who asked that question?
I don't know.
Because I've only addressed this 4 times. Problem set 2 is due tomorrow. You got 4 problems, 3, 4, 5, and 6. We did problem set 1 collectively. Mr. Velasquez, if you would look at that test, and if you need another copy, make sure you follow the instructions and solve for the variables that are listed there. Don't use the example. It should be something like B, handlebar mustache, parentheses, B such that B is greater than or equal to something. Why we used the example variables, I don't know. All right, and make sure a lot of you lost points by not following the instructions and putting the answer in proper format. All right, any last minute questions before we go? I know some of you guys have class here in about 6 minutes.
See you, sir.
We'll see you.